So here we need to find out the distance between 2 points, point A and point B. The coordinates of A and B are provided to us. Now in order to solve this problem, we'll have to use the distance formula. So let's try to employ the distance formula. So here, let's say we have 2 points, point A and point B, and the coordinates of both the 2 points are being provided to us. So here, the distance formula states that we have to take the square root, and underneath the square root, first we take the difference of the x coordinate, square it, then add it to the difference of the y coordinate and square its value. So let's try to apply this particular formula here. So in our case, we are given the value of the coordinate A. So A coordinate, that's given by A cosine alpha, comma A times A sine alpha. And then we have the B coordinate. So B coordinate has the value A cosine beta, and A y coordinate is A sine beta. So let us try to employ the distance formula. So first what we'll do, we will suppose that here the coordinates of point A, let's say it corresponds to x1 comma y1, and the coordinates of point B, let's say it corresponds to x2 y2, such that AB will be simply equals to, all we have to do is take the square root. Underneath the square root, first we will take the difference of the x coordinate. So that's A cosine beta minus A cosine alpha, square it, and then add it to the difference of the y coordinate. So that's A sine beta minus A sine alpha. So we're going to square this value. Now clearly we'll have to do some trigonometric manipulation here, only then we'll be able to get the correct option. So let's do that. Now starting with the first term, so here we have A as the common factor in both the two terms. Now what we can do, we can pull it out of the parentheses and square it. So we have A squared times cosine beta minus cosine alpha square. Then we have A also common a factor for the two terms within the parentheses. We can pull it out as well. So we have A squared times sine beta minus sine alpha whole square. Okay, so let's also take out A squared as the common factor for both the two terms and pull it out of the square. So we'll only have A, because A squared is a perfect square. So now we are left with A times square root of cosine beta minus cosine alpha whole square, added to sine beta minus sine alpha whole squared. So now what we'll do, we are going to expand each of the two terms within the parentheses. So we have A times square root of, now for the first term we have cosine squared beta plus cosine squared alpha minus 2 times cosine alpha times cosine beta. Then expanding the second term, we're going to get sine squared beta plus sine squared alpha minus 2 times sine alpha times sine beta. Fine. So this will be equals to A times, we have square root of, so we're going to combine cosine squared beta with sine squared beta. So let this be one term. Then we have cosine squared alpha added to sine squared alpha. So we have sine squared alpha, cosine squared alpha. Fine. Next, we're going to combine this term and this term by taking -2 as the common factor. So we have cosine alpha times cosine beta added to sine alpha times sine beta. Now we know that we have the standard identity sine squared theta plus cosine squared theta equals to 1. So this is an identity because it's true for any values of theta. So here in our case, for the first case here, theta is beta, and in the second case we have theta is represented by alpha. So both of the two expression or the identities is going to give us the value equals to 1. However, coming to the second one, so here we have cosine of alpha times cosine of beta added to sine of alpha times sine of beta. So this is nothing but cosine of the compound angle, which is alpha minus beta. So this is known. So let us substitute all this value. Now we have A times square root of, so since this identity is 1 and this value is also 1, so they get added to give us 2. So we have 2 minus 2, so this will be now replaced with cosine of alpha minus beta. Fine. Now what we can do, we can take 2 as the common factor. So we have square root of 2 times 1 minus cosine of alpha minus beta. The reason why we took 2 as the common factor, because now we can employ the identity that 2 times sine squared theta over 2, that correspond to 1 minus cosine of theta. So here theta is alpha minus beta. So that means our formula, or we can say our expression within the parentheses, is going to become, we have a times square root of, so we already have a 2, so this will get multiplied to the 2 of the coefficient of sine square theta over 2. So we have 4 times sine squared, now theta over 2, but theta is actually alpha minus beta, so we have alpha minus beta over 2. So that gives us the final result. So square root of 4 is going to be 2, so we have 2 times a square root of sine square alpha minus beta over 2, so that's going to be sine of alpha minus beta over 2. So this is going to be the distance between the point A and B. So that means the correct option is going to be option C. We have 2a times absolute value of sine of the angle alpha minus beta over